So team, this is session 10, Linux Application Programming Series, session 10, Introduction to Socket Programming. Agenda of the session is understand socket programming paradigm, learn BSD 4.4 Socket API, the functions, the calls, the prototypes, what they expect, see sample source for TCP-IP server and the client. We'll be creating client server programs using socket programming. Explore various capabilities of sockets, controlling socket, I/O notifications. Investigate socket patterns that illustrate socket API use case, and examine socket programming in other languages. As an example, we have one example which is considered here, that is Ruby based program. So concept, methodology is same. Whatever source I have shared, that source is a part of the discussion. The source is a part of this program, part of this topic, and the screenshots will be used from the same source code, working programs. In a way, it is a walkthrough of hands-on examples. To save time, I am not demonstrating because demonstration is a part of discussion and discussion is included in the lecture. So it will save your time and you should be able to practice that after opening the same lecture as a lab assignment. Open the system, start your program, you have the code, and understand one by one and start executing the programs and verify and customize the change wherever feel. You can do that. So in this session we will take a quick tour of socket programming. Now onward you will see two phases of the entire lecture. The lecture will be into two stages. Stage 1 will be a quick tour. Quick tour means working code with explanation of which line is used for what, which function is called for what, with an example. Second part, whatever functions, whatever APIs were used in the program in the quick tour, plus whatever additional capabilities they offer. In other words, the comprehensive understanding with the prototypes, with sample snippets of code will be discussed. So there will be two phases. So just have patience and wait for the complete comprehensive understanding of the function with the prototypes, with the return type, with the parameters it takes, with the options it requires, return value, everything. Wait for the actual function. First is working example. So as mentioned here, it will be a quick tour. We'll discuss the socket programming paradigm, elements of socket applications, and the Sockets API. Then the Sockets API allows us to develop applications that communicate over a network. The network can be local, private network, or public network. An important item to note about the socket programming is that it's neither operating system specific nor language specific. You can implement it for any operating system, for any programming language. First step, we need to understand the layered model of networking. I already explained the need of layers, so that part you already know. So we have application layer where application reside, the socket API, then we have TCP-IP protocol or UDP, that is a transport layer. Then we have network layer where we have IP, that is internet protocol, and then we have drivers and which are on the top of the physical layer. So starting from the bottom, we have physical layer, then drivers and the internet protocol, then transport protocol, transport layer where we have TCP or UDP packets and the socket API, and then we have the application layer. So the application exists at the application layer which interact. Below the application we define the socket layer. This is not actually a layer, but it is shown here simply to illustrate where the API is located. This is not layer, but yes, this is where we have our socket, where our API is located, which we make call. The socket layer sits on the top of transport layer, which provides the transport protocols. The network layer provides routing over the network. This layer is occupied by the IP, Internet Protocol. The physical layer drivers provide the means to introduce packet into the physical network. So that's the network layer, and it is a quick revision of your knowledge on networking, computer networking. So we should know, we should visualize where our socket lies, where we create our socket, and how it interact with the application and how it makes our application interact. The socket programming paradigm, the hierarchy. It starts from here, from the application. The application have a ports or the endpoint to which the application connects. The port corresponds to the protocol, so it is always in combination, IP address and the port, whether it is TCP or UDP. And then we have our internet protocol and the host interface. So this is the protocol stack where we are using TCP or over IP or UDP over IP. It involves a number of elements in the hierarchical fashion. At the top of the hierarchy is the host, where our host is lying. This is the source or destination node on a network to or from which packets are sent or received. That is either source or destination, or the vice versa, client or server. The host implement a set of protocols. Within each protocol there are set of ports. You have to look it from inverted tree perspective, make it upside down. So we have host, we have protocol stack, and we have ports. Each port defines an endpoint. This is what I mentioned here. The port defines the endpoint to which application connects. So by definition, host, as an example, the host interface has the network address. It is a reachable network node, the IP address. Protocol, specific protocol like TCP or UDP, and port is client or server process endpoint, where the client or the server connects to. I will define it. I'll make you visualize the port actually very easily, and that's very easy to understand. Because sometimes participants don't understand that actual definition of port. How do we define ports? For me, ports is very easy to visualize when I talk about my TV and the cable connected on the TV. I have only one cable, but I watch so many channels. I have only one radio set, but I listen to so many radio channels. So these channels are nothing but different frequencies. So every frequency offers me a different channel. So the same thing here, we can say the port can be defined in a different spectrum of frequency or spectrum of signal, or based on the protocol, based on the set of rules which define that port, which allow one particular set of communication, and they are numbered. Like FM channel, we have numbers. They define one specific frequency operates for a specific channel. Similarly, ports have a specific application, specific ports. And there are privileged and non-privileged posts. That's a comprehensive topic. Now, what are the elements of socket programming? We have the host. They are identified by their IP address. For example, 192.168.1.1. This is the IP address. Then we have protocol. The protocol specifies the details of communication over the socket. The two most common protocols used are transmission control protocol, that is TCP, and user datagram protocol, that is UDP. TCP is a stream based reliable protocol, and UDP is a datagram or message based protocol that cannot be reliable, that can be unreliable. Then we have the ports. The port is the endpoint for a given process or interface for a given protocol. This is the application's interface to the socket interface. Ports are unique on a host, not interface, for a given protocol. Ports are commonly called bound when they are attached to a given socket. They are numbered and they are split into two different ranges. Port number below 1024 are reserved for well-known services or privileged, or you can say for the services they are reserved. Port number above 1024 are typically used by applications. Addressing. It's a tuple, it's a record which consists of the protocol name, which protocol will be used, the host IP like this, and the port number. Put together in a curly braces, this entire record is called the addressing or the tuple. That's how we define the endpoint on network. Because endpoint require all the three important elements: the protocol, the IP address, and the port number. On which port, which IP address, what is the port? That is how we define the address of a socket. So remember this, in the programming we have to refer to these 3 points: what protocol, what address, and what port number. So that has to be a part of the network address part. So the socket is defined as an association of two endpoints that share the same protocol. Means on the same protocol, if we associate two endpoints for a same protocol, we call it as a socket. An example, in my diagram animation I will demonstrate and I'll explain that these are the two endpoints I have. And first endpoint is TCP 192.168.1.1 with this port number, and second endpoint is TCP 10.0.0.15820. How that is set, we'll understand that we could communicate via sockets in the same host. Port number assigned by the TCP stack are called ephemeral ports. Now let's visualize this between two hosts. So as I explained in the previous figure, we have the application here. Treat one of them as client, another as source, because we want to have the communication between the two. Let's say this is A, this is B, and this is the port number here, this is the port number here, where the application is tied up with the protocol stack on the TCP. So we are using TCP port, so TCP protocol, not UDP, over internet. This is the protocol stack, and on the other side we have this protocol stack. So this is the port number on application A, or the, let's say, server, and this is B, that is the client, and this is the port here, and this is the port here. Now and the IP address of the machine host is this 192.168.1.1 and 10.0.0.1 here. So these are the two servers or two systems with the corresponding endpoint. Our endpoint consists of, as I said already, the port number, the protocol, and the IP address. All three things included. So this makes the endpoint. So socket is association between these two endpoints. So this is the socket here. You see TCP protocol, the IP address and the port number, and TCP protocol, IP address and the port number. Association between these two endpoints is called the socket. That's how we can visualize the socket, how what exactly the socket is. Now we'll understand the implementation part. It will be very easy for you because the elements are important. Concepts was required and mandatory. The client server model. If you look at from the server side, we use a socket function call to create, then we bind it, then we open it for listening for incoming connections. On the client, we create a socket and we try to connect. But connection is not possible if somebody is not listening. So this must be implemented first up to this step on the server side. So when the server is in listening mode and waiting for connections, we have a function waiting in non-terminating loop which is waiting for incoming connections, and whenever there is a request, the connection establishment will happen, the connection will be established. Once the connection is established, they start data transfer, so read and write. This is reading the data, this is writing the data, and communication is happening. Finally, we close the connection. So when the connection is closed, it is waiting for incoming connections again. So these are the functions. This is the technical view of what functions are used to implement the socket programming at the client side and the socket server side. What functions in what sequence? 1, 2, 3, and then 4, and then here 1 and 2, and then this is happening here, and after that we are sending the data, we are connecting. Finally we close. In the most socket application, there exists a server and a client. Any application or any machine which is serving is called server, and which is taking services is called the client. The socket API provides commands that are specific to client and to server. You have seen that function calls here. Now you have definitely, by now you have understood, this session is going to be all about these functions which are mentioned in this slide. The first step in a socket application is the creation of a socket. The server requires a bit more setup as a part of the registering a service to a host. Bind call binds an address and port to the server to its that is known. Once we bound our port, we call the listen function for the server. This makes the server accessible, put it into listen mode. We establish our socket using connect at the client and accept at the server. The connect calls start three-way handshake. At the server, the accept call creates a new server-side client host socket. Once accept finishes, a new socket connection exists between the client and the server. In the data transfer phase, we have an established socket for which communication can occur. Both the client and the server can send and receive data asynchronously. Now, this was the quick introduction to socket, required functions, how it works, visualization of working. I'm sure by now you are in a position to answer. Those who are new to this concept, they are in a position to answer the question, what is socket programming and how it works, what all function calls are required. Up to this point, I'm sure this concept is clear. To the point, crisp, brief introduction, nothing is missed. Now we have to see some magic, some actual work. As I said, a quick tour to the socket application, socket programming. The sample application. We look at the socket API from perspective of two applications. One, a client, and a server that implement the daytime protocol. We are not doing too much of work here because our focus is not the functionality. Our focus is the working part or the flow, complete flow. For rest of the things, for complete working, And the realistic example, as I said, I have a project which I'll share with you tomorrow or day after tomorrow on day 5, which I announced already, that I have a comprehensive project which will implement all the topics discussed in this training, so that you have something to take away, something to implement after you finish the training. And remember, I'm not going to provide the source code. I have the source code, I'll show you working, but I'll not provide. Why? The reason being that I want you to type that code and commit mistakes, grammatical mistakes, and fix them. That will help you in the learning. So that project, because it will be shared after the training is over, so that will be more learning what next, so that you have revision of all the topics being covered in the training. That will going to help you. If I get individual requests after a sufficient duration that I tried and a lot of errors are coming, please help me with the source code. Obviously, then in that case I will share. We are not going to disconnect after the training. This protocol server is ASCII based, simply emits the current date and time when requested by a client. So the implementation part is very simple. Client will ask for current date and time, and server will send it the date and time. That's it. Client connects to the server and emit what is read. Means client will connect to the server, request for the date and time, server will give the date and time, client will display it and closes the connection. No further details, simple example. So the daytime server, let's now look at the C language server that implement the daytime protocol. Upon emitting the current date and time in ASCII string, the socket is closed and the server waits for a new client connection. So it is just offering the date and time. So functionality perspective, one simple example. But flow, it is a complete flow. So this is the simple application which is given in the session 10 source code file directory. The name of the file is dayserve.c. Now, first few lines up to line number 7, what we have is the header files. Socket, sys/socket, internet protocol, ARPA internet, inet, set booleans, stbool, stdbool, then stdio, time, string, uni std. So these are the header files, because we will be using some functions from here. Some of the contents are defined in dayserve.h header file. Define max pending connections 5, so it cannot allow more than 5 connections. So we are going to talk about 5 connections, possible connections 5. Now let's understand this program. Line 5 include time.h. No, it is line 5 include time.h to provide an interface to retrieve the current time in our program. In dayserve.h we have defined the max buffer, daytime serve port, and these fixed parts, so that we can use them as a constants, as literals. So like max buffer, then daytime server port, these are defined in dayserve.h. It's not that we could not have defined them here. We could, definitely, we could have defined them here. But to understand the overall concept, we are defining them in a separate file, so that it's not confusing for us. It makes it easy for us to implement and to follow the convention that all the constants and the library functions should be defined in separate files. That was the main reason why we are defining them in a separate file. We create 2 socket identifiers in line number 14. Here, integer, server FD, connection FD. So this is 1, this is 2. One is socket address structure. A socket address structure is defined in line number 15. That is struct, socket address, in, and server address. And a buffer to hold our string time in line number 16. Time buffer, max buffer size plus 1. And the time structure in line number 17, the time, how the time is stored, and this is the time structure. So these are the variables defined to hold our data and identifiers variables. So line number 15, 14 to 17 define our required variables. We create our socket using socket function in line number 19. Server FD is equal to the socket function which I mentioned. AFNet, what is the meaning of this? Socket stream, sock stream, and the value 0. So these are the three parameters is it taking. We need to understand these three parameters, what these parameters refer to. We specify the IP socket, that is means AFNet, specify the IP socket, AFNet domain. Using stream protocol, that is sock stream, define the stream protocol. And the stream protocol, I am sure you know that which is message protocol and which is stream protocol. TCP is the stream protocol, UDP is message protocol. So we are defining stream protocol here, not the message protocol which is UDP. So we are defining, that means TCP. So this defines the TCP protocol. This defines IP socket. So this is covering that part, that which protocol and which IP, which internet protocol IP, and which type of data, stream or message. The value 0, that is third parameter, defined the default protocol of the stream type, that is TCP. So default parameter is always the TCP, and this defines the TCP. At line 21, we initialize the address structure by setting all elements to 0. We specify our socket domain again with AFNet for IPv4 socket. The S address specifies the address, which is in this case is the address from which we'll accept incoming socket connections. That is source address. In address any to accept incoming connections from any available interface. We then define our port to use daytime server port. The H2NL, that is host to network long, and H2NS, that is host to network short. Take care of ensuring that the value provided are in the proper byte order for the network socket. Let's look at these line number 21 onwards. Go back. So line number 21 onward, what was referred in the slides? So line number 21. Memory set, server address, 0, size of server address, and initializing the values. Server address family is AFINet. Source address is H2NL. In address any, that means incoming address except from any. And H2NS from on which port to listen, that is defined by daytime server port, which is defined in our dayserve.h file, which I mentioned here. Daytime.serve.h define this. So this is defining which IP address, any IP address, which port defined by this port, what protocol, what family, AFNet family. So we are initializing these values in our memory structure for this purpose in this. Then we are binding this. Bind server FD struct socket address pointer server address socket T size of server address. Now that means we are binding the details, binding that namespace, the address space with this socket we have created. So the bind function is used here to bind the address structure with our socket. So whatever structure we created, we specified all the details and we bind that with our socket. The internet operates in big endian, otherwise known as network byte order. There are two options here, big endian and little endian. You can search internet for them. They specify what byte order will be specified. Host operates in host byte order, which depending on the architecture can be either big endian or little endian. This Earlier I used to get confused when this word came to me for the first time around 20 years back. I used to think it is a typo, that it should be Indian. So, but then I realized no, it is ending with. So that started with end. So this endian is coming from the word end. So how it is ending? What is the order actually? Little endian and big endian. For example, the Intel 86 architecture is little endian. Before a client can connect to our socket, we must call the listen function. That was called in line number 29. So same sample application, the portion which was missing, which I discussed. So 19 to 24 I discussed, 26 I discussed. Now listening is happening in line number 29. Listen, server, maximum pending connections, which is 5. You remember that I defined this value to be 5. While true, so this is going as the loop. Accept incoming connections for this socket. So we enter an infinite loop at line number 31 to 47. Line number 31 to 47, we get into the infinite loop to accept client connections and provide them the current data. How we are providing the data? That is interesting, that is coming here. Look at carefully this function. If it is valid connection greater than 0, current time, we are calling the time function, then void sn printf, time buffer, maximum buffer, and we are converting the current time into string and we are putting that into the buffer. That is what is the magic is happening here with this sn printf function. This printf function, sn printf function, is taking these parameter, the time buffer, size of the buffer, then converting the current time, that is C time, into string format and putting that into the buffer. That's why how we are initializing the time. At line number 32, we call the accept function with our socket server FD to accept a new client connection. When a client connect to us, the network stack create a new socket representing our end of the connection and returns this socket and from the accept function. Then a new client socket, that is connection FD. We can communicate with the client peer. Now same continued, the explanation of the same function. I am on the same program. At line number 34, we check the return socket to see if it is valid. Line number 34, as I said, if it is connected or if it is valid. If valid, we grab the current time at line number 35 to 38. We are grabbing the current time here. Passing this value to function C time, this is what I am doing here, C time, converts it into a human readable format used by sn printf to construct a response string, which is used, sn printf is used here. We send this to peer client using the connection FD socket using the write function. We are using the write function here. So we are sending this to write buffer. We are calling the write buffer connection FD time buffer string length of the time buffer. So we are writing the entire buffer. We are throwing that content of the time buffer into the incoming connection by using write function call. So whatever functions I discussed in the figure are demonstrated in this complete walkthrough of a simple example. We pass our socket descriptors, the string to write and its length to this function write. We close our client socket using the close function which ends communication with the particular peer. So this makes the complete example. We loop back to line 31 waiting for new client connection with the accept function. So this is the implementation of the server side. We could compile it and execute it using gcc-o dayserve.c with all the warnings. So I compiled it and then we execute it. When executing socket application that bind to well-known port, we must start from the root. That is an interesting point because we are using socket applications and that bind to well-known ports. The port number 13, for example, in our dayserve.h, the port number used is 13. You can change the port though. We are using a 13 port number, which is well-known port. So that means you must log in as root user to implement this program. So I'm using telnet to connect. You could simply test the server by simply using telnet to the local host from another tab. Open another tab, repeating from another tab. Open another tab and telnet to the server, because this server will hold the terminal. Either you have to use ampersand sign so that it run in the background, or it will wait for you. You have to press Ctrl C to stop it. It is non-ending loop because it is non-terminating loop. So either you use ampersand sign or you leave it and then move to the different terminal window. Take note of the line. From another tab, you telnet using the IP address and the port number, and you will get this trying connected to escape character, and this is the time returned by the request by the server, and then it is closing the connection, as I mentioned. So this is what the implementation is. So we retrieved the current date and time from the server through a socket program by creating a socket. So that is a simple walkthrough using all the functions of socket programming to complete a walkthrough of this example. Telnet client connect to our server and then print out that was sent to it from the server side, and this is the command I used, telnet localhost 13, and you'll get this kind of message. The summary. The network API. Now, as I said, I promised that first we will do a walkthrough and then we'll understand the functions in a comprehensive manner, the prototypes, the data types and returns and everything, so that after I finish this part, you will be more clear about the examples and the source code which you have. The networking API for C language provides a mixed set of functions for the development of client and server applications. Creating and destroying sockets. Now, as I said, the walkthrough has helped you in recollecting. Now it will be easier for you to recollect what we have learned so far. And you connect with the prototype, which I am going to discuss. A socket is necessary to be created with socket function. And this is a prototype of the function: integer, socket, integer domain, integer type, and integer protocol. It takes these three arguments. The socket object is represented as a simple integer. 3 parameters must be passed to define the type of socket to be created. An address to the stream, TCP, and the datagram UDP, a raw socket can be created. For example, this. My stream socket, IF internet, that is INET, socket stream, and the value 0. So these are the three. This is a normal integer type, this is also an integer type, and this is the third value, protocol 0. This specifies the default protocol. Datagram socket. So that was a stream socket, that is TCP socket, and this is datagram socket, that is message socket or UDP socket. A raw socket can be created using, you specify the raw socket raw, and you don't specify the third argument pass here, define that it is raw. So IP protocol to raw. So we are not using datagram or UDP, we are creating a raw socket. Now these are the three functions. We'll understand one by one all the details. The AFINET symbolic constant defines that we are using IPv4 internet protocol. The second parameter type defines the semantics of communication. For TCP, we use socket stream type. For UDP, we specify socket dgram. The third parameter could define a particular protocol to use, but only the type exists for stream and datagram, so it is left to 0. When we are finished with the socket, we must close it with close function, and we specify the socket identifier in the call. After the close is called, no further data may be received through the socket. Socket addresses. For communication over AF-INET, that is the internet IP address, the socket IP address in structure is used for incoming purposes, for naming purposes. You notice that while we created the variables identifiers in the first section just below the main, we use this structure, socket address in. What this structure is, what all values or components of this structure are, we need to understand that. This is the actual structure. So socket address in, so that is internet socket address. Full form is internet socket address. So we define INTL 16 underscore T SIN family, 16T SIN port, and then address, and then character say in 08. So these are the 4 different variables in this, and then we define this SIN address also, this structure in address. This in address is actually a 32-byte address, which is a TCP-IP address. That is the 4 octets of 1 byte each. For internet communication, we'll use AF-INET for socket internet family, that is socket, S for socket, IN for internet, and family. Internet socket family, you can say that. The field socket internet port defines our port number in the network byte order. Therefore, we must use host H2NS to load the port and H2HS to read from the structure. The field socket in address is through S address, a 32-bit field that represents the IPv4 internet address, and a socket address that permits incoming connections on any interface, and port number 48,000. Now we can get into the detail of what we defined. Integer server socket, structure socket address in, server address, server socket, socket type, we define these parameters, and then memory set, and then initializing them. Now this is the details of the snippet of the program code we used in our example. Create a client socket. Next, we create a socket address that permits a client socket to connect to our previously created server socket. This is how we define the client socket. Integer client socket, CLI socket, structure socket address in and server address. Client socket defined as socket, again the function call is socket itself. Type, the datagram, I mean the stream or datagram, what type of packet you want to use, and the third parameter as discussed, and then memory setting, and then initialization. The difference is that server uses address to bind to itself as an advertisement. The client uses this information to define to whom it wants to connect. If you notice here that this option, server address, SN, S address, and this is the server to which you are going to bind itself to. The bind, socket primitives bind. The bind function provides a local naming capability to a socket. Can be used to name either client or server socket. Prototype of this function bind is integer bind, integer socket, structure socket address, pointer type address, and address length. The socket to be named is provided by the socket argument, that is sock argument, this argument, first argument, and the address structure previously defined is defined by address pointer. When using a socket created with AF INET, the socket address in structure must be used. Therefore, we cast our socket address structure in the socket address. So this is how we cast it: structure, socket address, and we cast it here. Let me tell you, this sometime is not found in the internet when you search this example, and this is not mentioned. If you don't mention it through a warning, and the program may not work well. To completely, comprehensively, properly do it, you must cast it. Then we have listen function, listen primitive. Before a server socket can accept incoming client connections, it must call the listen function to declare its willingness, and that's we use with listen function. Integer socket, integer backlog. The socket argument, the first argument represents the previously created server socket, and the backlog argument represents the number of outstanding client connections that may be queued. Within GNU Linux, the backlog parameter represents the number of established connections waiting except by the application layer protocol. Other operating system may treat this differently. Then we have accept function. Is our final call made by the server to accept incoming client connections, returning a socket descriptor for a client connection. And this was the function used in our demonstration. Integer socket structure, same concept here, same the way we created it, we have the same parameters here also. And examples of accept represent the case in which we need to know who connected to us. This requires the creation of an address structure that will not be initialized. So this is the structure: socket address, client address, integer, client length. Then client length is size of structure address, and then we define this function: accept server socket, structure socket address pointer type, and then client address and client length. On return, this CLI sock, this variable CLI sock will have the value that contain the value of the new client socket, and CLI address will represent the address for the client peer which is connected. Then we have connect call, connect function. It is used by client socket applications to connect to the server. Client must have created a socket and then define an address structure containing the host and the port number to which they want to connect. And this is how we use integer connect, socket, and the process is same. You know the one function call, you will find the repetition, they have the same prototype. Socket argument represent our client socket. The server address structure, the second one, server address structure, second parameter represent is the server peer to which we want to connect. Finally, we must pass the length of our server address structure so that the connect no, we are passing then socket address in structure type. Then we have connect. The following code shows the sample example of connect. Same. This is a complete example of using the functions and structures defined earlier. Integer, client socket, structure, socket address, internet type, server address, CLI socket, we create the socket, memory set, and now it is the same repeating the connect function call here. The connect function block until either an error occurs or the three-way handshake with the server finishes. Socket input output. Two of the API functions, receive and send, are used to used exclusively by socket that are connected. An alternative pair, that is receive from or send to, is used exclusively by sockets that are unconnected, such as datagram sockets, because they are meshes, they are not stream, they are not connected always. So what are the functions for connected socket? Connected socket functions: send. Send is used to send a message to the peer socket endpoint, and receive is used to receive a message from the endpoint. And this is the prototype of the function. We pass the parameters socket, message, size and flags. 3 parameters. Similarly, receive, socket, buffer, length and flags. The send function takes first argument is the socket descriptor from which to send the message. Message is defined as a constant void pointer, because the object represented by message will not be altered by the send function. Whatever it is, no data type, nothing, you just use a void pointer, no type, you define it as it is, and it will be used by the send function without any alteration. The number of bytes to be sent is contained in the length. A flag argument can be used to alter the behavior of the send call. For example, you can define this a simple example: string copy. This is a call example. String copy, buffer, hello. So we are copying this data, and now we are using the call socket, void pointer, buffer, and string length of the buffer, and the value 0. So this is an example call of send function. In the example, our character array is initialized by the string copy function, as you noticed. This buffer is then sent through the socket to the peer endpoint with a length defined by the string length buffer. String length. When send is called, it may block until all of the data contained within the buffer has been placed on the packet's send queue. If not enough space is available to do this, the send function blocks until the space is available. If we want to avoid this blocking behavior and instead want to send the call to simply return, if the sufficient space is available, we could have set message do not wait or don't wait flag, like this, the third flag which was mentioned 0 in the previous example. This could be used as a third argument, the special flag. The return value from send parameter represent either an error less than 0 or the number of bytes that were queued to be sent. The receive function on the same lines. These functions mirror the send function in terms of argument list. So instead of sending the data pointed to be message, receive function fills the buffer argument with the bytes read from the socket. We must define the size of the buffer. The value returned by the receive function is the number of bytes now contained in the message buffer, or -1 on error. So we define maximum buffer size 50, character buffer, and then number of byte, receive function, now same used as socket, buffer, size, and the third optional parameter. At completion, n bytes, that is number of bytes, will contain the number of bytes that are contained within the buffer argument. Then we have a flag which we mentioned, which we used, like message peak function or message peak flag. I'm talking about the last argument. This flag, we could peek at the data that's available to read by using message peak flag. This performs a read, but it does not consume the data at the socket. This requires another receive to actually consume the data. So like number of bytes, receive, socket buffer, maximum buffer size, message peak. This call requires an extra copy The first will peek at the data and second actually read and consume it. So we are using handshake separately and putting the data separately. More often than not, this behavior is handled instead of an application layer by actually reading the data and determine the action, what action to take. Unconnected socket functions means we are talking about the UDP now, user datagram packets, message packets, unconnected packets functions. So the send to and receive from functions are used to send a message to the peer socket endpoint and receive a message from the peer socket endpoint. These functions have these prototypes: send to, the socket name, void pointer type message, length, unsigned flags, constant structure, socket address to, and integer to length, and receive from same prototype, similar prototype. This is used by an unconnected socket to send a datagram to a destination defined by an initialized address structure. In the send to function, the recipient is defined by the to structure that was mentioned. Do you recollect that? It was to was mentioned here. Destination size of okay. So structure, integer socket, message set, memory set, and then data address, port, that is port, and then address, source address, and then the send to function called here. Socket, buffer, length, 0, struct socket pointer, destination address, and then size of. Our datagram is sent to an application on the host 192.168.1 at port number 581, which is defined here S to NS. The destination address structure defines the intended recipient for our datagram. The receive from function provides the ability for unconnected sockets to receive datagrams. It is similar to receive function, but address structure and length are provided in this case. The address structure is used to return the sender of the datagram to function caller. This can be used with the send to function to return a response datagram to the sender. So here we use receive from function. This blocking call returns when either an error occurs represented by -1 or the datagram is received, return value will be return value of or greater. The datagram will be contained within the buffer and have a length of what is defined in the length variable. The from address will contain the datagram sender, specifically the host address and the port number of the originating application. Some options in the socket. Socket options permit an application to change some of the modifiable behaviors of sockets and the functions that manipulate them. For example, an application can modify the size of the send or receive socket buffers or the size of maximum segment used by the TCP layer for a given socket. And this is the additional options which we define here. So first parameter is fixed, second is fixed, fourth is fixed. Up to here everything good, but here we are defining the additional options. Set socket options, and we are defining the socket options in this. First we define the socket of interest using sock. Next we must define the level of socket option that is being applied. Level argument can be SOL socket for socket layer options, IP Pro to IP layer options, and IP Pro to TCP layer options. So what level of options you are specifying, you can accordingly define this argument, you can use this argument. The specific option within the level is applied using the OPT name argument. That OPT value and OPT length define the specifics of the value of the option. OPT value is used to get or set the option